Let's get this. No one remember what did we use here exactly. So look at this thing. In case you don't remember here. So if you have a magnet, north, south, the length of the magnet is 12. Now for small magnets, we know what is the formula, but if the magnet is, comparable to the length, so here the magnetic field on the axial line is given by mu naught by 4 pi 2 times mu naught by 4 pi m small r by r square minus L square whole square. That is a formula when the length is comparable here. This is a B equatorial, which is mu naught by 4 pi m by r square plus L square whole power 3 by 2. This is the magnetic field you do. You know, the magnets which are, who when the length and r are comparable. Now, how do you get this thing? Now, frankly speaking, this is a little difficult to remember. So what I do, I know how to derive this. So we have the North Pole, South Pole. So you can treat them as pole strengths plus m and minus m. I hope you remember magnetostatics. You can treat this thing as mu naught by 4 pi, the pole strength m by r square. So if you see, this formula kind of looks like E is equal to k q by r square. So k का place में we have mu naught by 4 pi. और 1 by 4 pi epsilon का place में we have mu naught by 4 pi q by r square. Right? And capital M is equal to m into 2L. Here the dipole moment is equal to q into t. So at this point, the magnetic field, so this distance will be r minus L, and this distance will be r plus L. So here the magnetic field will be mu naught by 4 pi m by r minus L whole square minus mu naught by 4 pi m by r plus L whole square. So you solve this, you end up with that answer there. So this would be mu naught by 4 pi, that will be m into 2RL, 4RL by r square minus L square ka whole square. And m into 2L will be this guy, so you'll get 2 into mu naught by 4 pi capital M r by r square minus L square whole square. Now, why this question is important? This is one thing they can ask you. They can also say like this: what if the magnet is, very, very close to this? If the point is very, very close, if your r minus L is very close, tending to 0, some constant value, right? That means points very close to the pole. There have been questions like this. Then they'll ask you, how does the magnetic field vary? Magnetic field will go as r power 1. If you're very far, if r is much, much greater than L, then your B becomes proportional to 1 by r cube. So that proportionality is important. When you're very close to the poles, how does the magnetic field vary? When you're very far from the poles, how does the magnetic field vary? When you're very close to the poles, the field will vary linearly. When you're very far, it will vary as 1 by r cube. Similarly, I can do the same thing here. This guy will push and this guy will attract, and you get the resultant. This is angle theta, so this is theta, this is theta. So your r will be root over L square This distance will be root over r square plus L square. So mu naught by 4 pi m by r square plus L square. And then you can simplify. You basically end up with this result. Clear with this? So now once we know this, now let's see what he's asking. He's saying the magnet is placed along the north and south. So north, south, east, and west. You kept your magnet the north pole towards your north, geographical north. So the magnetic field lines will be going like this. And anyone remembers how does the Earth ka magnetic field go like? The Earth ka magnetic field BH, it goes from south to north. And is saying somewhere on the equatorial axis, there is a neutral point. So at this point, the net magnetic field has become zero. So that means the equatorial mu naught by 4 pi m by r square plus L square whole power 3 by 2 became equal to the Earth ka magnetic field horizontal pH. Clear with that? You know the length of the magnet, you know the distance, this is your smaller, this thing, 3.2, everything. From there you can get m ka value. Once you got m ka value, then you will say this is m into 12, and then you're done. So here bar magnet, so this is 12, this is r, this is bh, everything. I hope you guys know the value of mu naught also. Mu naught is 4 pi into 10 power minus 7. Clear with this? This is a PYQ. Getting it? This is not some random question which I picked out from somewhere. This actually came in JEE means last 5 years. Mein. So they do ask such things. And if you don't know these formulas, and I'm telling you now, this is, for example, if you're very close to here, equatorial, what you get? You get r power 0. If you see in the notes, you will find that thing. The field does not vary there. You're separated by distance of 6 centimeters on the separated by 6 centimeter. Okay, so this is r by 2. No, this is 2r. The r is actually 3 centimeters here. Yeah. You said two neutral points, na? So this point and this point are neutral points. He took this as 6 centimeters. So r is 3 centimeters actually. Yeah. And if you see here, r and l are comparable. Right? Length is around 8 centimeter and r is your 3 centimeters. They're not small. You can't use an approximate formula, so be careful. And this is how you derive in case you forgot also. Let's get this thing. Easy one. So what does ferromagnetic do? Ferro and para will attract, dia will repel. Do you guys remember this thing? What is the universal property of all materials? Diamagnetism. What is the meaning of that? Any material, that is, even if you take ferromagnetic and paramagnetic materials also, even they have some form of diamagnetism. Universal property is diamagnetism. What about paramagnetic? Again, this will be slightly repelling. It will not be like huge repulsion there. This will be slightly attractive. And ferro will be like highly attractive. It's like ferro is simply paramagnetic on steroids. Ferro will do everything para does, but much stronger. So N1 and N2, N1 will attract, N2 weakly, and N3 will repel. Yeah, B option. Clear with this? Okay. Two questions. Which of the following explains the truth table? And what is the voltage across the load resistance RL? So let's try to simplify that circuit in the first place. That should make things clear. So you're giving A here, you're giving B here, you're giving A bar here, and you're giving B here. Then you give it to an OR gate. I think this looks like this is your A dot B, and this thing is A bar dot B. Then you're giving an OR, so that is A dot B plus A bar dot B. There's only one NOT gate. If there had been one more NOT gate for B, it would have been an XOR gate. So here you can take out B common, and this will be A plus A bar dot B. What is A plus A bar? 1 dot B. So this is 1. It's always coming to be 1 actually. Hmm. A, B, A bar and B. That's A dot B and A dot B.
Sorry to interrupt, but uh, tautology and B would, when we add them, it will give us the B set only, right?
What?
We'll get B as the answer, right? Not
Yes, it should
one.
be B.
1 dot B or B ना ठीक है B. It's not a plus. Then कितना the answer? Look at which wherever B matches. Yeah, this is the answer. What about the second one? So guys, remember the voltages for germanium and silicon? You should know that silicon is 0.7 and germanium is 0.3. That's your activating voltage. You need minimum that much voltage barrier potential before it starts working. So this thing is actually acting like a 14-volt battery. So 15 minus 0.3 minus 0.7 minus 4 kilo ohms, 4 into 10 power 3 into I is equal to 0. So we get a 14 by 4 into 10 power 3. So voltage across the load resistance will be 14 into 4 into 10 power 3 into 2.5 into 10 power 3. That would be 7 by 2 into 2.5. That would be 14, 3, 17.5, 8.75. Clear with this? So be careful. Don't assume they are like, ideal diodes. An ideal diode meaning it will have zero resistance. It does not mean the barrier potential is zero until unless it is not mentioned. So always be careful with the barrier potential. That's it. There's nothing there. Once you the diodes, right? Once you got the circuit, it becomes simply like your current electricity equation. Let's get these two. So what is it? Frog can be deviated in a magnetic field by current due to because of diamagnetism. If you're balancing, Mg must be balanced with something, right? Attraction won't balance it. And frog is diamagnetic. So rock can be deviated in magnetic current. This thing. That's due to the diamagnetic nature. The repulsion is balancing the weight. I think there's a copper rod, I guess. Rod or Todd is suspended in a non-homogeneous magnetic field region. Now again, a copper, right, is not a ferromagnetic material. So copper is basically diamagnetic. That is the main catch or nothing else. That you should know. So the Todd will be in equilibrium when it will align itself with. Now understand something. It repels, right? A diamagnetic metal repels. So where it will go away? It will go away from the strong field and it will go towards the weak field. So the Todd will be in equilibrium, will align with in a region where the magnetic field is weakest and parallel to the magnetic field and perpendicular parallel B option. Meaning if you have a magnetic field B bar, right? And for example, say, let's say these are the field lines. And let's say here it is B1 and here it is B2 and P2 is greater than B1, something of this magnitude is more. So not like this actually, it gets repelled. So it will try to go away from the field. You guys remember this thing? When you put a diamagnetic material between two magnets, if you put some diamagnetic powder, how does it align? The center may the field is the weakest. So the diamagnetic powder will become a pile like this. This is how the shape will form between the magnets if you keep it. So basically the center may the field is weak and near the poles the strong field. Right? Since it is an equilibrium, torque must be equal to whatever is that m cross b. So therefore m bar must be parallel to b bar. So it must be parallel to the magnetic field and it will always go towards the weakest thing. Clear with this? In a non-homogeneous magnetic field. Copper, if you just take one single copper, maybe it is unpaired, but copper, you don't get it in a single atom, na? When they form crystals, don't they just, when they form the lattice, they will get paired up, isn't it? And you need to be careful there. Are you taking a single atom or are you taking a crystal or, a lattice? Maybe if you, what you said, single atom, it would have been right. So, what about this thing? Two short magnets, each having magnetic moment m, are displaced at a distance of 2d apart, with axes perpendicular to each other in a horizontal plane. The magnetic induction at a point midway between them is. Let's see whether you'll get the picture. First one, did you guys get the picture? Let me show you in case you didn't get it. So we have one magnet like this, north, south. He's saying the axes are perpendicular. So this is your magnetic axis. The other guy is like this, north, south. And he's asking what is the field at this midpoint here. So basically for this left magnet, it will be the axial line ka formula, which is 2 mu naught by 4 pi m by r cube. Distance is 2d, right? So that would be d and d. And due to this magnet, I will maybe color this in black. This for this point, this will be an equatorial line. Again, it's a small magnet, so I can use an approximate formula, which is mu naught by 4 pi m by d cube. Since both are perpendicular, you have to square them and add them. Mu naught by 4 pi m by d cube. That will be root over 1 square plus 2 square. D option. What about the next one? This thing I explained you in the last class. Do you guys remember why the shape is made this way? So the reason the magnets are cut this way is because, so we wrote it somewhere here. So the reason why this magnet is cut in this way is because the field will be always perpendicular. That is the reason you make that concave shape. Right, so B bar is always perpendicular to the area vector. Therefore, torque will be NIAB. Getting it? Because if the torque changes with angle theta, then you'll not get a proportionality. Then you can't say I is proportional to the angle rotated by this thing, so it becomes a mess. Let's get this thing. We have two identical PN junctions connected in series with a battery. The potential drop across the two PN junctions are equal in which circuit? Hope you guys remember what is forward bias and what is reverse bias. See, when you're in forward bias, you have negligible resistance. Getting it? And we have a small resistance. Almost negligible, but there is some resistance. When you're in reverse bias, it's a large resistance. So simply think of like this. You will get equal potential when both have same resistance. So for equal potential drop, they should have same resistance. So who has same resistance? So this is forward bias and this is forward bias. So they will have same resistance, right? This is reverse bias. This is a reverse bias. Even they will have same resistance, right? Clear with this. So they're just large resistances and small resistances. Just think of them like that. Clear? So forward bias might have resistance in some ohms and reverse bias might have in something like 10 power 5 ohms or mega ohms. So there are two answers for that. Which of the following statements is incorrect? Wait, I did something mistake here. This will repel, right? That's not attracting. If it is repelling, then it will go perpendicular to the magnetic field. If it was attracting, then it would have been parallel to the magnetic field. So be careful with that. This will actually repel. It's for attraction, then this will align in the direction of B bar. Meaning, think of like this here, the magnetic field is going this way, but this material will be aligning perpendicular to it. What about this guy? Anti-parallel? It's a rod, na? It's not a single atom. So if you have a rod, when there's a magnetic field, this guy is getting repelled, this guy is getting repelled. So both the sides are getting repelled, and the only thing they would prefer to have is this way, isn't it? What about this thing? Think of like this. A rod is simply some copper ka powder. Now, if you think about this situation here, imagine instead of putting a full rod, if you put some copper ka powder, make copper into fine granules and put it between them, then what would have happened? Then the copper would have aligned like this, isn't it, in the middle? So now just combine all the granules. Doesn't that become a rod? Making sense? Think of that way. And that's what I also thought suddenly and said it's not parallel. I know these things can be confusing. If you would have seen them, exam suddenly when they come to you will go up. What about this guy? Which of the following is incorrect? The drift current in a PN junction is from N to P. Now here you need to a little context here. What is happening in case you forgot? So how do you construct this thing? You take a wafer and then you introduce P type from one type and N type from one side. When you do that, P type and N type, you have an excess of holes here and you have excess of electrons here. Now remember, P type and N type are still neutral normally, but then because of this excess of holes and electrons, the electrons will start jumping here. This is because of diffusion, right? So due to diffusion, electrons jump from N type to P type. That means the diffusion current is opposite. because the flow of positive charge is called current. So diffusion current is from P type to N type. Now, as these things are jumping continuously, because of this whole central part starts getting charged. This thing gets negatively charged. So in a PN junction, P is negatively charged and N is positively charged. Be careful. If you take only P-type material or if you take only N-type material, what charge do they have? They're neutral. Only P-type, only N-type is neutral. But when you put them together in a PN junction, suddenly they become charged. And now because of this, these things will create a counter electric field, right? And this is pushing back the electrons again. So, right? So these electrons are moving because of the drift. So now there's a continuous flow. Electrons are jumping back here, the field is pushing back here. Electrons are jumping here, field is pushing back here. They reach a steady state. At some point, the diffusion current becomes equal to the drift current. So electrons move from P to N due to the electric field. This is called drift current due to the induced electric field. So the drift current is from N to Q, N to P. So the drift current is from N to P. This is right. I hope you're getting the difference. Diffusion current and drift current, there are two different things. Diffusion is coming because of concentration. Drift is coming because of your electric field. I hope the scenario is clear. So finally you reach a equilibrium and you get that forbidden gap in the middle. And I hope you remember the forbidden gap depends on what? The width of the forbidden gap depends on 1 by doping concentration. Last time likha tha humne Zener diode and avalanche diode mein. The drift current is due to electrons only. True. That is because the electric field will pull the electrons. There is nothing called a hole, remember? Hole is absence of electron. In reality, there is nothing called exactly a hole. Silicon is preferred over germanium for making semiconductor devices. That is also true. The energy gap in germanium is more, that is wrong. So that is your answer. The energy gap, so even if you don't know ABC, right, D is the most straightforward, you could have figured it out. The energy gap in germanium is how much? 0.3, na? Silicon is 0.7. वो तो clear था, that is a mistake. Now remaining 3, you don't even remember what it is, we do it. But why is silicon preferred if germanium was so small? Silicon is cheap. You get it in abundance and it is cheap. और कुछ नहीं है. If germanium is abundant, people would have actually used germanium. So if cost is not a factor, we would try to make germanium chips. But clear with this? So incorrect, that is the thing. But that was actually easy to solve even if you don't have a context of what is happening, all that story I told you. But still, better you know all that stuff. Let's see. Optical instruments. This didn't come, na, till now. A compound microscope has a magnification of 30, assuming that the final image is formed at the least distance of distinct vision. If you remember, there are two cases. One is your normal adjustment, one is the distance of least vision. Find the magnification produced by the objective lens given the focal length of the eyepiece is 5 centimeters. Now, for people who don't remember, listen, I'll just brief it up fast. First thing is a simple microscope. You should definitely go to the notes and check out this stuff. So a simple microscope is simply one single lens, right? When you put an object here, the light ray goes here, the light ray goes here, and when you extend them, this is where you get the image. This distance is u. So the magnification is given by theta naught. Hope you remember what is that. So theta is the angle with instrument, theta naught is the angle without instrument. So this thing comes out to be d by ue. That is your magnification. So for normal adjustment, what is normal adjustment? Far point. That means the image is at infinity. So the observer who is looking at the lens will think image is at infinity. That means you must be at focal length. So the magnification will be d by f. For distance of least vision, that is when the image forms at capital D, which is roughly around 25 centimeters. This is also called as near point. That means basically your V ka value is minus 25 centimeters or capital D. So you can actually use the lens ka formula 1 by V minus 1 by U is equal to 1 by F and solve all that. You end up with the magnification is 1 plus D by F. So these are the two magnifications for normal adjustment, far point or distance of least vision is 1 plus D by F. This is for simple microscope. What is a compound microscope? In a simple microscope, we have a problem. If you use single lens, there is something called achromatic error, achromatism. Heard about that? Remember? Why does that come? That comes because the refractive index is different for different wavelengths, right? All the different colors won't meet at the same point. The image becomes a blur. So if you use any one lens for magnification more than 4, you start getting achromatic errors. So we use multiple lenses. So there comes compound microscope. In a compound microscope, we use two lenses. This is called objective lens, FO. This is called eyepiece. Eyepiece meaning that is where the observer is. This is where the object is. So again, what is the idea here? The object which is here, first we magnify this object. So we take the object here and we magnify this object, make it big, and see this through the eyepiece. So basically, a compound microscope is nothing but use one lens to make the image bigger and see that image through a simple microscope. Are you getting the idea there? A compound microscope is one simple microscope plus a lens. So this distance is your U naught, and this distance is your V naught, and this distance is your UE. So here magnification will be magnification of objective into magnification of the eyepiece, which is V naught by U naught, and this will be D by UE. Now, this D by UE will again get two cases. Remember, D by FE or D1 plus D by FE. This is for that far point. This is for the near point. So this is the actual formula. The length of the microscope is given by V naught plus UE. But in NCRT, if you remember what they did, the magnification formula, right? When you actually simplify, this thing ends up to be V naught by F naught minus 1 into D by FE. This is for the normal adjustment or the far point. They only give this formula for NCRT. And look at this thing. This you get a pretty good theoretical question. For high magnification, F naught FE should be what? Small or big? This itself is a theoretical question. In a compound microscope, to get high magnification, the focal length of objective and eyepiece must be what? F naught and FE must be small. If not F naught plus FE must be small, then V naught by F naught must be much, much bigger than 1. So this becomes V naught by F naught and D by FE. And the length also, right? Since the, what do you call that? The F naught and FE is much, much bigger. So this guy will become almost equal to V naught. The formula becomes LD by F naught FE. So do remember this. It's a direct formula from NCRT. They'll give you the length of the microscope. They'll give you the F naught and FE and they'll ask you for magnification. You can't get that formula directly because that involves a lot of assumptions. F naught plus FE is small. So length of the microscope, which is V naught plus UE, becomes approximately equal to V naught. So V naught we replace with L. And if you remember the astronomical telescope, here also the story is same. So this is your F naught, this is FV. The only difference here is the light rays are already coming from infinity. So they're going to meet at the focal length here. This guy would be F naught. So this guy would be UE again. So here the magnification will come out to be, you take this to be angle alpha, this is beta minus F naught by FE. alpha by beta, that is h by fe. Yeah. Magnification would be f naught by fe. This is for normal adjustment. The other case would be it is f naught by fe into 1 plus fe by capital D. This is for that near point. There. These are all the main formulas there. You should definitely check out the notes in case you forgot. Now coming back to the question. A compound microscope has a magnification 30. So that is your net magnification. Assume the final image is formed at the distance of least vision. So that is D. Find the magnification produced by objective given the focal length of the eyepiece is 5 centimeter. So here magnification would be magnification of objective into 1 plus D by Fe. He's saying this is 30, this is M naught, this is 1, D is 25, and this is 5. That guy would be 6. So M naught would be 5. Clear with this? If we had said the final image is formed at the infinity, then the formula A1 would have been missing. Then the answer would be 6. He said the image is formed at the distinct of vision. Clear with this? Because the final image is at infinity, this is the formula. If the final image is at far point, would have been used D by Fe. Then what about this guy? Find the magnetic power of a compound microscope whose objective and eyepiece are of focal length 4 and 5. The object is placed 5 centimeters beyond the objective. Assume that the final image is formed at the least distance of distinct vision. Okay, again, same formula basically. Okay. So what is the object का focal length? Object का focal length is 4 centimeters. The object is placed at 5 centimeters. So we use the lens formula 1 by V naught by 1 by minus 5 is equal to 1 by 4. So we get 1 by V naught is equal to 1 by 4 minus 1 by 5. 5 minus 4, V naught is equal to 20. The magnification ka formula is V naught by U naught. That is the magnification of objective. Image is formed at the least distance of distinct vision. So 1 plus D by Fe. So V naught is 20, U naught is 5, 1 plus 25, and Fe is 6. That is 4 plus 100 by 6. How much is this? And 24 by 6, that is 2 40, 20.6 something, 20.7 something you're getting. Clear with this? These are little different. So do check it out. There, I wrote down all the stuff here, just in case you need. I'm sure some of you have forgotten it. So let's see if you remember this. The dispersive power and the mean angular deviation for crown and the front glass are given omega and omega dash. D and D dash are the deviations. When the two prisms are combined, the condition of zero dispersion by the combination is. What is zero dispersion? If you send white light, it actually splits into different colors. This angle between them is your angle of deviation, which is delta violet minus delta red, which is A into mu violet minus mu red. And omega would be theta by delta average, which is mu violet minus mu red by mu yellow minus 1, or mu average minus 1. So he's saying the dispersion is 0. So theta plus theta dash is 0. And what is theta? That would be A into mu violet minus mu red plus A dash into mu violet dash minus mu red dash. The condition for zero dispersion. Okay. And from here we get, so mu violet minus mu red would be omega into mu average minus 1. But I also know deviation delta is nothing but A into mu average minus 1. So if I take that mu average minus 1 and substitute here, this guy would be delta by, you wanted A now, so multiply A on both the sides. A into mu v minus mu r. This would be omega into A into mu average minus 1. That becomes omega into deviation. Therefore, omega into d plus omega dash into d dash is equal to 0. Third option. I'm sure you remember this formulas I did last time, but this is how the questions would be. You have to mix up them, combine them, and do them. I hope you guys remember this thing, na delta, right? And you remember this thing, and you remember omega ka formula. If you see, we are just playing with these three. If you say dispersion is 0, meaning theta and theta dash are cancelling out. If they say deviation is 0, then delta plus delta dash is 0. But they have only two cases. If the prism is up, it is positive. If the prism is down, it means negative angle. Keep this in mind. Telescope has an objective focal length of 100, eyepiece is 5. What is the magnitude of telescope? So basically this least distance of distinct vision, right? These are little rare. Like most of the time they'll ask you for the normal adjustment. So there, this is the formula I gave you. This is the distance of least vision. You know the formula, you will get the thing just like that. You don't remember, then you're gone. You will have to literally solve. So F naught by Fe, 1 plus Fe by D. Substitute the values, you'll get the answer. Get the next one. 2-bar magnets oscillate in a horizontal plane. The Earth's magnetic field time period is 3 and 4. If their moment of inertia ratio 3:2, then the ratio of their magnetic moments is vibrational magnetometer. What is the formula? T is equal to 2 pi root over I by mb. 2-bar magnets oscillate time period. The moment of inertia are given ratio of magnetic moment. So T is proportional to root over I by m. So T1 by T2 is root over I1 by I2 root over M2 by M1. So T1 by T2 is 3:4, I1 by I2 is 3 by 2. Then you get M2 by M1. Square on both the sides, then that would be 9 by 16 is equal to 3 by 2 M2 by M1. Therefore, M1 by M2 would be 8 by 3. Yeah. Clear that. Don't forget, vibrational magnetometer is very important. Every year it is popped up in some or the other paper. There are like 6 to 8 sessions. It will come in some session. Semiconductors. You guys remember what is the symbol mu? Mobility. Remember what is mobility? Drift velocity per unit electric field. So that is called mobility. That is one thing you should know. Then we also know current I is equal to NEA V drift. So from here, if you substitute this thing, it will become NEA V drift will be mobility mu into electric field. So we get I is equal to NEA mu into E. E can be written as voltage by resistance. So what do you want to find here? What will be the magnetic current? What is the total magnet of germanium? So, and that is your electric field. Electric field is nothing but the potential difference by length. So that I can find battery ka voltage is 2, length is 0.1 meter. That is 2 by 0.1. That would be 20 volt per meter. There I got the electric field. The area is given, so I know A ka value. If the block is intrinsic silicon on 300 Kelvin, find the electron and the hole currents. N is given as 1.5 into 10 power 16. Since it is intrinsic, remember what is intrinsic? There are no impurities. Therefore, number of electrons is equal to number of holes. Intrinsic meaning pure silicon. So number of electrons is equal to number of holes is equal to the 1.5 into 10 power 16. So what is the total current? So I total will be NEA mobility of holes into electric field plus NEA mobility of electrons into electric field. So you have to find this is called hole current and that's called electron current. Generally, we ignore hole current in conductors because they're very small, but in semiconductors, they do actually an appreciable amount. What happens if I use germanium instead of silicon? If I use germanium, then mu ka values will change, isn't it? You just adjust the values of mu and you'll get the answer. But these formulas are important. Right? Mobility, this word, and this relation is important. I think if you know these two things, you can handle most of them. And be careful with this. When you're adding for semiconductors, the current is not only due to hole current, electron current, you have to add the hole current also. So in case you forgot, those are the terminals. They can simply ask you, find the dimensions of mobility, and you'll have no idea what they're talking about. Mobility is the drift velocity acquired per unit electric field. If you take the drift velocity and put it in I is equal to NEA/VD, that gives you current. Clear with this? I can even play more also. They can ask you find the conductivity. So if you see I is equal to NEA mu into E, this can be written as NEA mu V by L. So this is L by NEA mu is equal to V by I, which is resistance. So L is NEA mu is equal to rho L by area. So we get rho is equal to 1 by NEA or 1 by sigma. So this is NE mu. NE mu. This is conductivity. This is the relation between conductivity and mobility. N is the number of electrons per unit volume. E is the electron charge. So this is another thing you can play with it. They can ask you find the total conductivity of the system. So total conductivity would be NE mobility of electrons plus NE mobility of holes. This would be the total conductivity of the semiconductor. Again, I hope you're getting this. So again, a lot of terminologies, you have to be careful there. With all the numbers and all, I'll just put that solution also here just in case. There, this was that whole thing we are talking about. They might not ask whole thing. This is not a JEE question, so they might ask you bits and pieces of it. I thought this was having everything. I kept it. There, I hope at least you remember that stuff now. What I was talking about. What is mobility, conductivity, and all that stuff. Lattice constant is simply the distance between the molecules. in the lattice. So what is this? So what happens here when you increase the distance between them? Again, try to understand what is conduction band. Do you guys remember? Conduction band is the common energy level where the electron can start jumping from one atom to another atom. So imagine if you have two atoms and they're like close, right? So this orbit and this orbit. So if your electron can somehow reach this orbit, then it can freely move across the atom, isn't it? But now, for some reason, if you increase the distance between them, didn't the orbits increase? Now it has to travel much more distance in order to become a into the conduction band. So the conduction gap will increase. So I'll put the picture there. So this is like this, and this is like this. So just so let's say this is the one orbit, and this is the second orbit. This is one, and this is second. So basically, the second orbit is a common orbit. That's your conduction band. Maybe 2s. Right? But now, because you made it bigger, now it has to go more. The gap increases. The third orbit is your conduction band. So energy gap increases. If automatically if energy gap increases, the other two will also start compressing. So energy gap will increase, and the conduction band and the valency band, this energy levels will decrease. Then what about this thing? Lattice constant is decreased. Hmm. Wait, I think I said something wrong then. Hmm. Let me check that. If you're bringing them closer, then what would happen? Hmm. Okay, let me check this again. I think maybe I'm saying lattice constant is reverse. Yeah. Let me check that thing. Something went wrong. I think I got it wrong. I thought it was increasing and I did the whole thing. And luckily answer matched. Then I must have goofed up something else. Okay. What about the third one? Let me see this thing. This will be pending. According to the band theory of solids, what can be said about relation between the band gap width and the tendency of metal to conduct electricity? Yeah, lesser the band gap, the more easily electrons can jump, so the metal becomes conducting. So lesser the band gap, more insulating. Wrong. Greater the band gap, wrong. See, na? If you have a small band gap, meaning it's conducting. If there is a big band gap, it is an insulator. That thing, I'll check it out. This we did, I guess, no? We did this thing before. What kind of material is this? Let's get that. What about this thing? Now, if you look at here, one thing is clear. This is not a conductor because there is an energy gap. And second thing, if you see, there are some free electrons moving around here. But if you observe something here, one, two, three, four, there are four electrons. One, two, three, four, five, six, there are six holes. If this was a pure intrinsic semiconductor, the holes and electrons would have been equal. But here there are more holes than electrons. So here the number of holes is greater than number of electrons. The open circles denote holes and the filled circle denote electrons. Okay. So this is a p-type semiconductor, right? You just have to count the holes in the electrons. If see, first thing is clear. Either this is an insulator or a what do you call it? A semiconductor. In case if it is an insulator, you should not have a single electron here. But there are some electrons there. So it is a semiconductor. But you can see there are more electron holes than electrons. So it is a p-type semiconductor. What about this guy? A potential divider circuit is connected with a DC source of 20 volt, and this is straightforward. And light emitting diode of 1.8 volt. So this is 1.8 volt, and this thing is 3.2 volt. So you need 5 volt. That means this length must be 5 centimeters. This must be 15 centimeters. Easy. So if you apply at least 5, the Zener diode will be in breakdown and the current will flow through that. Anything less than 5, the Zener diode will not get activated. It will become like an open circuit. Mm, What is this thing? Yeah, do you guys remember how a solar cell looks? In a solar cell, there is no voltage. Transistor, there's no amplification here. This is actually Zener diode. You should know this thing. If you see, there is a breakdown here. That's a Zener diode. What about this thing? In an experiment, find out the diameter of the using screw gauge of the following observations are noted. The screw moves 0.5 meters on main scale in one complete rotation. So this is your main scale division. Total divisions is 50. So least count will be main scale division 0.5 by 50. That is 0.01 mm. Main scale reading is 2.5 mm. Okay. And the instrument has 0.03 mm negative error. So the correction is positive. So how much should I add actually? Do you guys remember negative error? What happens? Think about this thing. What happens in a negative error? In a negative error, how do you know in this thing there is a negative error? You can't see the zero. That scale, because zero will be actually inside. So if they had given a picture, this is how it would look. On the scale, the zero would be inside. You can't see the zero. And you will see some number here. Let's say something like 20. And let's say this thing has 50 divisions. Now try to understand the meaning of this. If you rotate the scale, if you look at that head scale, the readings would actually look like this: 0, 1, 2, 3, so on, and this is 49. Now, if you rotate in this direction, the numbers will be 1, 2, 3, 4, 5, 6, 7. But if you rotate in the opposite direction, then what numbers will you see? 49, 48, 47, 45, isn't it? So when you actually see 20 here, what did you do? If it is actually 20, that means you rotated in this direction 30 divisions, isn't it? Because when you count the numbers, you'll go from 0, 49, 48, and so on. You went till 20. So correction is not 20, but 30. So he's saying the instrument has 0.03 mm negative error. So he didn't give the divisions actually. So this thing is 2.5. So I think he actually gave you the result directly, I guess. So this is 2.5 mm plus 45 divisions. That would be 45 into 0.01, and negative error, so correction is 0.03. If they had given some numbers, then you have to calculate. This would be how much? 2.98. Suppose if it is not the negative error ka value, and if it is that what we are thinking, then it would have been 2.5, 45.001. Then it is not 0.03. This should have been 0.47. Then this would be 2.98 and 0.47. That would have been 3.45. And that option is there. So it is 3.45 actually. The instrument has a 0.03 mm negative error. You're getting this? So meaning what he's saying, when you rotate the scale, you can actually see third division. That means you rotated 47 divisions backward. 3.42, okay? That is 875. 3.45 आ रहा है ना जैन नहीं?
So 2.95 में भी लैंड 0.47.
सही है. चलो, luckily that is not there. I thought would have marked 3.45, I guess. So I think when he gave the negative error, it is a net value only there. I don't know the answer for this. So 2.98 only looks appropriate, because if what we think, that would have been 3.42. Okay, so let's keep it clear. If they had given like this, meaning this is the correction. If they give you a division like this, then we will do this. Okay, let's be clear with that. That would be the last one for this thing. So we still, this lattice constant now, was just checking it out. इसका explanation ये था. Oh, just checking. I think I got it wrong. So when you take the atoms here and when you bring them closer, he's saying when you bring the atoms closer, the electrons come closer to the nucleus, so the attraction force becomes stronger. So it becomes more difficult for electrons to escape. So this word is right only. It is the distance between the molecules. That actually makes more sense. The molecules are brought closer. The electrons are strongly held by the molecule's nucleus. Basically, you are shrinking the orbits also. I think they're getting closer. Therefore, they're more difficult to. So therefore, the binding energy increases. Therefore, the energy gap increases. Energy gap is the energy required to jump into a higher orbit. There, that would be an explanation. ठीक है, take a 5-minute break. We'll start the speed test at 7:20. Come back in 6-7 minutes. We'll start the test. You can just be online. Need to leave. Go, Joe. Just fresh up and come. हाँ यशविल कुछ है क्या?
PN junction अगर reverse bias है, so can you just draw the diagram of the PN junction once and it's reverse bias? Can you just draw it?
Biased.
Reverse biased.
Which reverse biased? Okay. मतलब you connect P here, N here, तो N को positive connect करो, P को negative connect करो.
Now N is like it is electron rich, right? And P is
Right.
hole rich.
हाँ.
तो अभी जो इलेक्ट्रॉन्स है वो डायरेक्टली राइट साइड में जाके वो कैथोड में नहीं जा सकता है क्या? Still, it would follow the same convention of current as positive
Same
charges
thing,
going
na?
from.
Like initially when you pull, so that would only happen, na? If you're pulling electrons, you know what will happen. This starts becoming positive, this becomes negative. At some point, they will stop going, isn't it? वो तो होगा ना. What you're saying is true. तो यहाँ पे भी barrier potential आ जाएगा ना वापस suddenly.
अच्छा वो बैरियर पोटेंशियल की वजह से वो
It'll
EMF जो
stop
generate किया वो
eventually.
it will
You,
stop it.
yeah. You just can't keep pulling the electrons forever, na? So voltage across this will become equal to the voltage across the battery.
Okay.
Hmm.
And in that lattice one, what if the distance between the molecules were increasing? So it would have been reversed or would it have been the
Reverse
same?
होगा. It would have been reversed.
Reverse होगा ना?
Basically, I think mistake मेरा ये है. I was thinking like this. वो 1s and 2s and 3s orbit na, I was thinking them as if like, it is a fixed value. It is not like that. How do we define the energy level? K, Q1, Q2 by R square, na? That R is the distance between the nucleus and the electron. Right? So it depends on the distance actually. It does not depend 3s क्या है. That way. That would be the right way to see. I just took it as a distance and I thought it would be like that. That was a mistake. ठीक है? चल आ जाओ 5 minutes में.